Hi, this is Mr. Max. So what I'm doing these few days, I'm going to do revision questions for grade 10 to grade 12 learners. Now, some of the questions in this particular series are learners who are doing grade 10 and 11. However, there are some questions that are applicable to the learners who are doing grade 12, the old syllabus. In a nutshell, I have got a question here, and you're supposed to shade this region. A union B complement. Now, it is quite something when you are dealing with questions on shading. So I suggest you are numbering the regions. Like, for example, I will number this region here on the outside as 1, and this particular region here I'll number as 2, and here where they overlap I label it 3 and 4 here. So what I'm going to do them step by step. So I'm going to list all the elements of set A. Set A is only 2 and 3. And I'm going to list now all the elements that is not in set B. So things not in set B is 1 and 2. Now the union of that is everything here combined. So you do not write the 2 twice. So it's 1, 2, 3. So that tells me I should shade region 1. I should shade region 2 as well as region 3. So my shading will be something like that. Okay. So the numbers are quite useful in shading, and it doesn't take that long. But whatever method works for you. All right, so I have here 2 overlapping sets, A and B, as you can see. Now, they are saying A union B. That means if you join the elements of A and B, all of them here, you get, they are supposed to be 40 or 70 elements. So when you create an equation, it's simple. You just add them. You say x plus 11 plus x minus 3 all squared, that quantity there, should equal to 70. So perhaps the next questions that they're going to ask you now to show that this simplifies to some sort of quadratic equation. Then you're supposed to factorize, and then you're supposed to solve and find the correct answer. Okay, so let's look at the other parts of this question. All right, so if I bring all of the questions back, so now they want us to show that the equation that we just had created in the previous slide, it simplifies to that. Again, if I bring it back, x plus 11 plus the quantity x minus 3 all squared equals to 70. So first you need to handle the stuff in the bracket, this binomial x minus 3 times x minus 3. Well, you clean that up, you obviously going to eventually end with x squared minus 6x plus 9. So what I'm doing is I'm rewriting everything. Okay, that x is here, the 11 is here, the 9 is here. So when you clean that up, you bring over your 70, you should get the required equation. Now you factorize this. That means you look for two numbers, multiply, give you minus 50, and when you add them gives you negative 5. You can pause the video and try to arrive at those answers, but you should get that the numbers are minus 10 and positive 5. So you factorize. This is not an equation, you just factorize. You see, that's an expression there. Now in part B, Roman 2, they want you now to solve the equation, which should not be that difficult anymore. Since you have the factors of x minus 10 and x plus 5, you simply let them equal to 0. There's no need to go and do things like the quadratic equation formula or God forbid completing the square. No need for that. So if you have two quantities and they give you a product of 0, it implies that one or the other is equal to 0. So x minus 10 is already equal to 0, such that you put a value here, it gives you 0 for that bracket. But then you realize that x equals to 10 or that x equals to negative 5. Now we have solved the equation. So you're not going to invalidate any answer. They said solve the equation. Part C says the number of elements that is in A intersect B complement, which basically is this little x region here, right? You're supposed to find that those number of elements is x. So we now already determined what the values of x are. So we can't have negative values of x. Okay, so when we are now going to choose, we choose our correct answer. In this particular case, x equals to 10. Now they say find the number of elements in set B. That means 11 plus this x that we now have decided, which is 10 minus 3 all squared. And that should give you 60 elements in set B. Right, so I have a third question and also something on Venn diagrams and set notation. So there are 30 students in a class, and 20 of them study physics, 15 study chemistry, and 3 study neither physics nor chemistry. So you need to complete this Venn diagram here to show this information. Now there's many ways that you can do this. Perhaps if I have to show you how you can do this using algebra. Okay, so in algebra, we know that this region here should be 3 because they are the ones who are not doing either one of the subjects, and we don't know how many learners are doing both the subject. But I know that physics, there are 20 learners who study physics, and I also know that there are 15 learners who study physics. But if I have to consider this little region here, it should be then 20 minus x, because this x is already included there, and this particular side has to be 15 minus x, such that the whole set C for chemistry gives you 15. Now if I have this equation, or if I have this information, I can actually form an equation. I can let my equation equal to 30 for the universal set, so I know that the universal set is equal to 30. So you can actually go ahead and say, wait a minute, 20 minus x, all right? Now, maybe I should just quickly change the color here so that you can see, plus x, okay? So that you don't need to change the color though, I'm just putting it out there. Then plus the 15 minus the x, maybe you can add that little 3 also that is outside, should give you the universal set, should give you 30. And then you go ahead and you clean this up and you solve the equation. In a nutshell, you should get something like 38 minus x is equal to 30. And then if you solve for x, I'm going to find the learners who are doing both chemistry and physics, which means I'm going to get the answer to this part of the question, Roman 2 here. Now, if I have to solve this, then subtracting both sides, 38 from both sides, right, that is just going to give me that this is an 8, minus x is equal to minus 38. Obviously, when you divide throughout by negative, then x is equal to 8. So now, if you know that x is equal to 8, then that answers that particular part. And now you can actually go ahead and you can complete. So here you have got 20 minus 8. Here you'll have 12. Here you'll have 8. And here you'll have 7. And that is how you complete that particular using the algebraic method. Okay, so you can pause the video and you can see how I did that. All right, especially the equation. Right, so I am going to clean all that stuff up. I'm going to use another method in order for me to solve this. It's not necessary that you use the algebra method. If you also know the following method, you can also apply that method. Okay, so please don't forget to subscribe to the channel, and also once you have done that, make sure that you click the notification bell so that you can get notified every time when I upload a video. I'm going to do quite a few of these to help you prepare for the examinations. Right, so the universal set is 30, and I know that physics, 20 students are doing physics, and I know that 15 students are doing chemistry, and I also know that 3 of them, they don't do any one of the subjects. All right, so what I have here, the students who study both, so I add 20 plus 15 plus 3, and I know that should be more than the required universal set, and I subtract 30. That gives me the learners who are doing both the subjects. Okay, now the learners who are only doing physics will be the 20 minus this 8, because you can't write 20 here, then it becomes 28, so it has to, the whole set P should add up to 20. So if there is 8 already, then this should be, okay, that's correct, that should be 12. And then you do the same concept to find the ones who do chemistry. You have to take away the 8 here in order for you to find that particular region, which is 7. All right, so basically now I have answered the question. I have completed the Venn diagram, and the learners who did both, I also know there are 8. Okay, so we put in here a little question here on probability. So they choose a student at random, and you were supposed to find the probability that the student studies physics but not chemistry. So it means you just go to the learners who do physics. There are 12, all right, out of the total number of learners, and that simplifies to 2/3 or anything equivalent. 12 over 30 will also do. Right, so there is another part to that question. They say a student who studies physics is chosen at random. Okay, could be a little bit confusing, but here they just want you to find the probability that when you choose a student at random, the physics one, what is the probability it doesn't study chemistry? Now we know the probability that you study chemistry, so not chemistry is 1 minus our previous answer, or you just then go to 12 over 20, only the ones for physics. All right, so what I'm saying, if you could refer back to, you can also see the way you can approach it. You can say 1 minus the probability that the learner only studies physics or chemistry, and our previous answer was this particular value. And when you do that, you are going to end up with the same probability as the one that we worked out here. Okay, right. So then there is another part to the question. Obviously, it brings in two bags. Bag A contains 6 white beads and 3 black beads, as you can see. So in total, we have 9 beads in black A. In black B, you have got 4 black beads and 6 white beads. So in total, we have got 10 beads in bag B. Now you're supposed to, when you choose one bead at random from each bag, you're supposed to find the probability that both are black. So you take 3 out of the 9, the total, all right, and then you multiply that by the 4 out of the 10. That is how you do this particular probability. All right, you can have the 12 over 90 or anything equal to that particular probability. Okay. Then they say at least one of the 2 bits is white. So what do we do is we have now calculated black. So we're going to say 1 minus that probability. It's an easy way to find that, okay? Anything that simplifies to 13 over 15. So there you'll have a mixture. You have white, white, or black, white, and stuff like that. So the majority of that, 13/15ths, is going to be the answer. So when you are finding at least one of them are white, you say 1, all of them, minus the probability that you only get black. And that helps quite a lot. Right, so I've got the fourth question here. Bus tickets cost 30 Namibian dollars for an adult and 20 Namibian dollars for a child. There are A adults and C children on the bus, and that means we don't know the total number of, we don't know the exact adults and the exact children, but we know that there are 52 people on the bus, and the tickets cost 1,390. So you're supposed to find the number of adults and the number of children on the bus. Now there are ways to do that. One of the ways is, well, you can create 2 simultaneous equations or 2 equations and solve them simultaneously. So I'll first consider the people. I know that the people should give me a total of 52. That is the adults plus the children. My second equation, if I look at the money that is involved, I know that the children are paying, or the adults are paying $30, and the children are paying $20, and in total 1,390 should be collected from 52 tickets. So this creates then 2 equations, all right, which can be solved simultaneously. So I just go ahead and I use substitution method. So you can use any one or other method that you want to use by eliminating and stuff like that. So I created an equation, made A the subject of the formula. I could have made C the subject of the formula or transpose the equation or the formula. Anyway, I'm going to take this value and substitute it in 2. Don't substitute it in itself. That doesn't make sense now. All right, so that leaves you to multiply out with that 30. Then obviously you're going to end up with 1,560 minus 30C plus 20C equals to that. And then you clean this up well so that you can get a value. And then that means then there are 17 children on the bus. So you can go back here, use equation 3 or equation 1 in order for you to find the adults. And that means that there are going to be 35 adults on the bus. Okay. So on the next slide, I'm going to show you another method, but it practically is basically the same thing. There basically, I didn't have to create two simultaneous equations, but I had to use powerful reasoning that I also used here. So what I use here, I say let the number of children be x, since we don't know how many children there are. So that means the adults then should be x less than, all right, the total number of people. So if there were 10 children, for example, then the adults would be 52 minus 10. Just a reasoning I'm using there. Now, if that is the case, we now know that they pay $20 for the children and $30 for the adults. But you see, you have to put the 52 minus x and brackets. This basically brings you to same what we had previously. It's just now that we are now looking at it a bit differently, okay? But the solving of it is rather the same. Get rid of the brackets, collect like terms, solve for x being 17 adults or 17 children rather, and the adults will be 52 minus that 17, obviously giving you the same 35. So any one of that would do. Right, question 5 I throw in there. Now, please, for those of you, we are not talking here about three-legged chickens and things like that. All right, so it says in a farm there are horses and chickens, so we know that there are 116 heads. Now here, very important that you obviously does make sense that the heads of all the animals should be 116, and the legs you must be careful. Okay, so a horse has got 4 legs and chicken has got 2 legs. So you're going to create two equations, and maybe you can use letters like I decided to use H for the horses and C for the chicken. So first equation, this one here, 282, deals with the legs. The horse has got 4 legs. A chicken has got 2 legs. All right, so I don't know what type of chickens are there that have 3 legs, but this is not that type of question. Then the total heads will be the number of horses plus the number of chickens should be 116. So there you got it. You have 2 equations. You can use basically any method to solve them and find one and the other. Right, so what I did is I'm dividing equation 1 by 2 because I can do that by eliminating. I can divide or multiply. So when I do that, I get 2h plus c is equal to 141. That means 4 divided by 2 is 2. 2 divided by 2 is 1. 282 divided by 2 is 141. So I created another equation. And then I bring equation 2 back. So now I can actually eliminate by subtracting equation 2 from equation 3. All right. So if I do that, I'm going to get that h is 25. So therefore there are 25 horses. I can go back and use my formula. So if there are 25 horses, that means there should be then 91 chickens at the farm. Okay, so tomorrow, be on the lookout. I'm going to put 5 more questions on random topics. All right, and make sure that you pause, try to do the questions on your own, and then you check how I solve them. Okay.